Hi, my name is Lalith. I'm a PhD student at QIMP. We are hosted at Medical University of Vienna, as Thomas pointed out before. To tell a bit about myself, I'm from India, you probably guessed it, and I did my bachelor's in biotechnology in India. And since I was a bit bored with biology, I moved to a mainframe company where I worked as a developer. I did the job for a year, and since I found it to be a bit monotonous, I looked for master programs in Germany, and I applied for a biomedical engineering program in a university called RWTH Aachen. Here I got to understand a lot about medical imaging modalities, and this is where I really fell in love with hybrid imaging modalities, and that love actually made me do a master thesis in attenuation correction, where I developed an attenuation correction algorithm for a PET MR. And finally, I wanted to do a PhD in hybrid imaging as well. So that's where I moved to QIMP in Vienna, where we try to perform absolute quantification in clinical routine using a fully integrated PET MR. Let me explain in short about my PhD thesis. So what's being currently done right now? So if you go to a neurological PET examination, what they do is they take a radio tracer, they inject you with the radio tracer and ask you to wait for 40 minutes in the resting room. And after that, they take you and put you inside a PET scanner and they scan you. What you end up is a PET image where each voxel actually tells you how much of radio tracer is being accumulated. It's more like telling you, hey, there is FDG here, but it doesn't tell you if it's FDG, the non-metabolized form, or the metabolized form. What the clinicians are interested in this one, the actual metabolized one, which actually tells you how active a particular cell is. So this is the current scenario. The PET images are basically semi-quantitative in clinic. They have a term for it called standard uptake values, which are like semi-quantitative measures. This works for oncological cases, but for neurology, it would be much better if we could do absolute quantification. So can it be better? Yes. We could do something called absolute quantification, which is a superior version of the traditional method. And PET actually started in this way. But for performing absolute quantification, you actually need two things. One, you need the dynamic fate of tracer as a function of time. So you take the patient, put him inside the scanner and inject him with radioactivity and take multiple shots of the brain in different time points. So this is one which you need. It's a dynamic data set. And the second one which you need is an arterial input function. The amount of non-metabolized tracer as a function of time. And you can get this information traditionally by making an arterial cannulus. So you make an arterial cannulus and sample blood for every 5 seconds or every minute or 10 minutes as time progresses. As you can probably imagine, this is an invasive procedure. Not only this is an invasive procedure, it's also time consuming, and that's why the doctors hate it and they don't want to do such a complex method. So they always opt for SUVs because it just takes 20 minutes and it's much more faster. What we wanted to do is we wanted to bring back absolute quantification as PET was meant to be. So we started investigating on absolute quantification and we found that no one really likes an arterial input function because it's invasive. We tried to recreate this arterial input function in a non-invasive manner by using a fully integrated PET MR. What we do here is that we take the structural information and we take the functional information and we do advanced data analysis and data correction. We recreate the arterial input function in a fully non-invasive manner. We use these structural information and functional information and recreate the arterial input function, and then we perform the absolute quantification. By doing so, we obviate the need for an invasive procedure, and finally, this could provide additional diagnostic benefit to the patients as well as the clinicians. So this is a short introduction about my PhD thesis. If you would like to know more about my PhD thesis, kindly click the link below and I'll be happy to share more. Thank you.